Hello, everybody. Hi, thank you for joining my How Does Machine Learning Work stream on our Global Hack Week. Super excited to see all of you here. Hopefully everyone got some good rest in between the last stream and this one. I think it's been 2, 3, 4, couple hours, maybe 3 or 4 hours. So hopefully y'all got some time to rest and some time to take a break. Hopefully y'all played, what was it? Bob Ross mini paint with Cecilia. Hopefully y'all enjoyed that. I think that's a super cool mini event. Really glad Cecilia is doing that. And I hope y'all had fun at that event if you got the chance to go, and I hope you've had fun at the stream so far. Yeah, make sure you say hi in the chat. Say something about the streams that you've been going to so far, and if you've liked them. That's a funny joke. Yeah, that's funny. Hopefully you submitted to the Hello World Challenge. I know it's like everything's about MLH, but no, it's an MLH plug. Hopefully you submitted to the Hello World Challenge, and all of these challenges are beneficial for you. So hopefully you submitted to that challenge and make sure that you can get the points that you get for those challenges. Hello, Songham Active. Hello, Trisby. Hello. Glad to see everybody joining in. Keep the hellos coming. Let me put the check-in link back up. This is the check-in link. Let me also put it in the chat. This is where y'all are going to check in to make sure that your attendance, like participation, I don't know, you being here is counted for this stream. Hello, Vienna. Hello, Abiolax. Hello. Ooh, I see a lot of people. Nice. Yeah, so make sure y'all check in. Oh my god, no. Why does that say 1712792? Oh, damn it. I put the wrong link in the chat. It's 12793. Yeah, so I'm active. You are in fact correct. That is the wrong link. I accidentally put my How Web Apps Work stream link there. So I just did that and I had that open and I was like, oh, this is the only MLH link open. Should be this. Turns out it was not. Hello, noob. Yes, you are correct. Damn, really? I swear it was 12793. 12793. Bruh. Oh my god. Oh my god. Okay, I'm clearly. Oh, it's 12794. Yeah, because 12793 was Cecilia's. Bruh. That is completely on me. So sorry for those of y'all that checked in at that. Let me actually go ahead and change to that. Can you tell that I'm tired? Sorry, that is the correct updated link, 100% guaranteed because I just checked. Please check in at that link. Do not let my mistakes bar you from checking in and getting those points that you deserve for staying throughout this stream. By the way, in case you didn't know, this stream is a 2-hour long stream. It'll be going for 2 more hours. And yeah, we're going to be covering a lot of really cool machine learning topics. And we're going to be doing some very fun interactive live demos. So hopefully y'all are hyped and excited for that. Don't worry, all the mistakes I just made with the check-in link are not going to be made in my stream. It's going to be a good stream for sure. I will not make mistakes. Don't worry. I went through the code like a bajillion times before I did this to make sure that everything would work. And it does work. So it's going to be a great stream, and I'm super glad that y'all are here. I'm going to keep the check-in link up for a little bit longer just in case, because I know I kind of messed up in the beginning, so I'll keep it up if anybody needs it. But today, we are not here to just talk about ML, like machine learning, so I'm going to shorten the word machine learning to ML. You might hear me say ML a lot. That's because I don't want to keep saying machine learning every 2 seconds. So we're going to see how machine learning works in real time. So by the end of the stream, you'll be able to know how machine learning works from start to finish. You're going to have a working machine learning model, and you're also going to be able to have the skill set, the basic skill set, to explore a couple more advanced environments. So I want y'all to get your Python environments ready. Some people use Jupyter Notebook, some people use Google Colab. I swear I tried using VS Code. If any of y'all have gone to any of my streams, you know how much I love VS Code. And so I was trying to do this stream in VS Code, and I was just getting an insane amount of errors. Like, I usually don't spend that long like working on the code for these streams, but like I swear I spent like 3 hours. I spent the past 3 hours, like right after I ended my last stream, I was like, oh, let me get ready for this stream. I spent like 3 hours trying to fix the code, and it was just like so many crazy import errors. Like, I don't know what was going on, but it was not working in VS Code. The second I switched over to Google Colab, all my errors went away. So we're going to be coding in Google Colab for this stream because I was not able to get VS Code working. I think it's because I accidentally installed a dependency in my local environment, and I messed something up when I was trying to download something else. So even after I created that virtual environment, I was getting that problem, and I was like, yeah, okay, I'm done with this. So I gave up. And we're going to be using Google Colab. And no worries, honestly, I really like Google Colab. Like, it's pretty cool. I'm still a VS Code lover. Like, VS Code is it's always been there for me, but Google Colab is actually pretty cool. Yeah, it's just amazing. Like, it's like you can create new cells, and it's just cool. So maybe I'm a new Google Colab component, but yeah, so feel free to use whatever IDE you want, but I'm just going to use Google Colab just for purposes of like knowing that it works. But yeah, it's simple. Yeah, Google Colab. If you're talking about Google Colab, yes, I completely agree. Google Colab is simple. You're practicing LangChain in there. Very nice. That's really interesting. But yeah, it's super interesting, super easy to use a lot of different programming languages. And yeah, it's super useful. So hopefully y'all also like Google Colab. If you don't know what Google Colab is, let me send y'all a link to you basically just have to have a Google account, which I'm pretty sure most of y'all have. You can just go to this URL right here, and then you are going to go ahead and click, oh, let me delete that. Oop. You're going to click on this URL, and then you're going to a new notebook, and it'll open up a new notebook where you can write your code in. And don't worry, I'll work step by step with you on how to get into this code and how to work through it. So don't worry about it. I will be here for you the whole time. And this is going to be super interactive. I'll ask y'all questions. You're going to like respond to me in the chat, and we'll use some of your input in the demos. A big goal of mine during these streams is to be super interactive. So I want y'all to be as active as you can. I know you're following along. I know you're paying attention. I know you're tired, and I know it's a lot to ask. But if y'all could interact in the chat when I'm like, hey, like, what do y'all think? Put a 0 or a 1 or something like that. If y'all could interact with me, that'd be 10 out of 10. So that we can keep moving and keep getting on to more topics. Hello, Permit. Why can't I check in? Okay, it worked now. Okay, good. Looks like you solved that. Great. 10 out of 10 problems. 10 out of 10 problem solving skills. Good job. I am glad the check-in worked for you. If anyone else is having any other problems, just let me know and we can work it out. That is a constant theme that you will hear throughout this stream. If you're having any problems, just tell me. I can't help you unless you tell me, because obviously I can't see y'all. And no shame, like if there's something that you want to send to me, but you don't want other people to see it, you can just send it in the chat and I won't pin it up on the screen, and I could just like subtly answer the question. So send whatever you need help with, ask me whatever questions. That's why I live stream, so that I can help y'all live and not like try to help you like after the fact after I've streamed. So I'm kind of curious what the experience levels in the chat are. So if y'all have never written ML code before or heard of machine learning, or you don't know what it is, I want to see a 0 from y'all. If you've done at least one project in ML, I want to see a 1. If you've done 2 or more, I want to see a 2. So this is that part where I was talking about interaction. I love seeing oh, hi. Trispy says 0. Okay, McCool says 0. Oh, Permatus didn't even give us a number. Permatus said expert. Okay. Anam 0. Abilax 2. Soham 0. Solop 0. Beanie 1. Noob 0. Oh my god, I love this interactive. I'm not, no. Interactive? Interaction. I love this interaction so much. Ooh, Jelly says 0. Okay, so it's looking like we've got a lot of beginners in this chat, which checks out given that this is beginners week. But either way, I'm super glad that y'all took the time to come out. Oh, Vienna 0.5. I like that. I like that. Yeah, that makes sense. You're like kind of a beginner, but you know, a little bit. Oh, new. You already said 0, dog. But 0 is no experience. You're like just new to ML. 1 is like you've done like one project, and like 2 is like you've done a lot. And like, you know, these are flexible numbers. Like these are just like my basis. But if there's something else that you feel like doesn't really fit these numbers, feel free to put like Permatus did expert. Maybe 2 wasn't enough, and if Permatus just wanted that expert level. Ooh, in that case, 1.3. Okay, I like that we went from 0 to 1.3. I like that. That's good. Number of hot dogs I will get to give you. Ooh, I actually don't have hot dogs, unfortunately, so virtually, for sure. Coincidentally, I was planning to do... You know, I'm not really sure what that means. If there's more context, let me know, but I am not too sure what that means. But thank y'all for the interaction. So it's super nice to see what levels y'all are at. And yeah, are we doing Laura training in the stream? It's my favorite thing to do. We are not. This is a very basic beginner level stream, so it's going to be like more like ML models, more basic concepts, and just covering a little bit more like things that are more basic. Like if you want to learn machine learning, these are the things you should know, given that it's beginners week. But for sure, if you're interested in more complex trainings, definitely look out in the future because that might happen. Ooh, Andrea and G course on ML. Ooh, Coursera. Okay. Look at y'all already jumping like how many like 2 hours ahead and giving the resources already. Ooh, Mosh Hamadani. Okay, has a really good tutorial. Okay, so for those of y'all that had a 0 and said that you were beginners, check out these resources. Check out this person, this link, and Andrew NG course on ML. Apparently these are really good resources for y'all, so definitely keep an eye out for that. Thank y'all for sending that and helping your community out with learning machine learning. I'm not really gonna go a lot into like more advanced topics. It's gonna be mostly basic. We're gonna be doing like interactive parts, so it's not just like me teaching. So even if you have a bit of experience, you might gain something from the interactive part. But like not really too many like pro items, I guess. Oh, that's nice. Apparently, Andrew NG's course provides financial aid. Thank you, Soham. So if y'all need that, for sure, make sure you check that out. So I probably should have done this before we got too into it. But hi, if you haven't been able to come to one of my streams, I'm Varshini. I'm a coach at Major League Hacking. And a fun fact about me is I have a blahage. This is like a blue whale. I really don't know how else to describe it. It's like a life-size plushie. Like you can see how long this is. I think it's a shark. I can't remember. Blue shark, blue whale. I think this is a shark. This is a shark. I'm lying. This is a shark. So yeah, that's my fun fact. This used to be a really big thing in Major League Hacking, that like all the coaches would have a blahage, and I finally got my own. I went to Hack the Six last month, and I got a blahage, and now that's my fun fact. That is forever going to be my fun fact. Yeah. Ooh, should I be an expert to enjoy this live? Oh my god, no, you don't have to be an expert in Python. Don't worry at all. We are going to be coding in Python, but I have instructions and I have detailed explanations for all of this code. So even if something is written, like, don't worry, I got you. We're going to go through it. I'm going to explain what the code means and everything about it. So don't worry about it. This is not a swag. Nope. this is just for me. Some of the MLH coaches have blahages. It was just like a thing that other coaches used to do. It's not a swag. It's just like a stuffed animal that I have that I thought was cute, and that's my fun fact because now I get to show the shark every time at every stream. Because my fun fact used to be like I've moved 13 times, which I think is interesting, but like I'm kind of sick of saying that. And since I'm at home when I stream and I have my blahage, like I will be showing off my blahage. Yes, Vienna's correct. It is an IKEA shark. You get them at IKEA. They're blahage, like Swedish, I think. Yeah, I love IKEA. Oh, hello, Tyler. Great to see that you are joining us as a beginner. Lovely. We have some good content coming up for you. So yeah, that's a little bit about me. This is our agenda for today. So I know it might look like a lot, but I've just sectioned it off into different sections to make it a little bit more manageable and a little bit like more digestible since it's in like chunks. So we're going to talk a little bit about like why machine learning in general, and then like what machine learning is. So this is just our quick context for the next 2 hours. But in general, machine learning is really, really important right now for like career growth, for increasing the problem solving power that you have, and for innovation. So if you wish that you could automate something, machine learning can potentially help you with automating that because it can help you train a machine to learn something over and over again and develop something. So you can kind of contrast what we had before. So before machine learning, we had like traditional programming. So you can think about traditional programming like you write rules, which are like the codes, which are the code lines that you write. These are rules. And then you give data. And then the computer gives you answers based on these rules and data. With machine learning, though, you give answers and data, and the computer figures out the rules. So you can kind of see that shift where before computers needed data and rules, and then they would just come up with the answers, like basically like a calculator. But with machine learning, you give them data and then answers for what the data is supposed to give you, and then the computer figures out the rules. So if that sounds a little convoluted, here's a quick example. So like if you think about spam detection, before machine learning was super popular, spam detection would be like if an email contains certain phrases, such as like buy now, exclusive only, offered, leaving soon, something like that. Your email filters would mark that as spam. However, with machine learning, you could show the computer like hundreds and thousands of spam emails and non-spam emails, and then tell them like this is spam, this is not spam, and then it learns patterns so that you can have your computer detect whether or not something is spam without you coding rules. Like think about the infinite amount of ways that spam could happen. Like there's so many different phrases and people can always get around them. With machine learning, the computer's figuring out the rules, so the computer can run thousands of analyses and figure out these rules just so that you don't have to. So if you can think of something that's really hard to code with rules because like there's an infinite amount of rules, there's like too many rules for you to think of, like the rules are too complex, but it's easy for somebody else to understand based on examples, that's exactly what machine learning is used for. And you can kind of think of machine learning as coming in like 3 main types. So the first main type is supervised learning. So this is where your model will learn from labeled examples. So you can imagine like I gave you maybe like a stack of like flashcards that you use to like flip back and forth studying for a test. So if you have like one side is a photo of an animal and the other side is like the name of the animal, like dog or cat. You can look at these flashcards and eventually you'll be able to guess the right animal without even flipping the card over because you know, you're like, you see animal, you're like, oh yeah, that's dog. And that's supervised learning where the answers are known while you are training the person, or in this case, the model. The second type is unsupervised learning. So here, there's kind of no labels. There's no like animal, there's no dog. The model is given a bunch of data and it's just kind of told like, have fun. Yeah, you got it. And it's basically just like you have to figure out what goes together without having the answers. So the model basically tries to find patterns like clusters, relationships, all on its own. And this is in contrast with the supervised learning where the model already has the answers. So the model can try to find out patterns if it wants, but it's already got the answers. But with unsupervised learning, it has to do that extra work. Finally, you've got reinforcement learning. So this one's more trial and error, and this trial and error has rewards and penalties as well. So again, going back to like our animal example, like if you try to teach like a dog how to like you're trying to teach a dog a trick. If the dog does the trick and it's right, you give it a treat. If it's wrong, there's no treat, right? So over time, like this is kind of like Pavlov, like the dog learns actions that do these tricks equals a reward. And so what this means like with machine learning is like the algorithm for the machine basically learns how to maximize the amount of rewards that it's getting over like a long period of time. So this is how we're able to implement machine learning. So we could do a lot of these different like types of learnings, but we are going to be mainly focusing on supervised learning, and the other two will make sense in a little bit, because supervised learning is basically just like learning how to ride a bike with training. Oh yeah, no, don't worry. The slides are not supposed to be moving. I basically just did like one slide for each of the sections, because we're going to be coding for the majority of this kind of slideshow, or for the majority of the stream will be coding. So I'm just like yapping at you for a little bit so that I can get you into the basics of the concepts, and then we're going to switch over to code. So there is no slideshow. I am in the correct place. Thank you for double checking though. Um, what's this for? Will the stream be posted on YouTube? Yeah, so this is our How Machine Learning Works stream. This is part of the technical track that is for like how things work. I'm running 4 streams this Global Hack Week about how things work. And this is the second one in that series. The previous one was how web apps work. This will be posted on YouTube, and this is for the Global Hack Week. So let me know if you have any more questions. Yep, no worries. So yeah, I guess you can try to think about supervised learning. Like you get the basics of how a model learns from data, and then you kind of take that training set off and then explore more complex methods. So today we're going to be focusing mainly on supervised learning, and then you'll be able to train your own model. So there you go. I did switch the slide. We're going to be talking a little bit about like core concepts for machine learning. And like we covered a little bit about core concepts like in that first part, but like more about like even more core concepts is data. So data is super duper important for machine learning. And I think this is a really big misconception with machine learning. I feel like a lot of people just think like, oh, it's like robotics and computer science, like very like computer science heavy, but it's also very data heavy. The reason for this is because data is like the fuel behind machine learning. And if you don't have data, your model can't learn. And that's why data is super important. In supervised learning specifically, we're going to break our data into features and labels. So our features are kind of like our measurable inputs. So we can think about this like if we're trying to build like a house or something. We have a house and we have inputs for like what this house is going to look like. This can be like bedroom, square footage, things like that. And then our labels can be what we want to predict. Maybe like house prices, house stories, like house occupancy, house like location, things like that. So basically the features would be clues and the labels are answers. So if you were predicting someone's like health score, for example, you could include features like maybe age, maybe like gender, height, and then the labels would be like maybe like healthy, unhealthy, super healthy, and things like that. So like for an example, if we were going back to this like house example, if you wanted to predict housing prices, your features could be like bedroom size, location, the year the house was built, and your label could be like the price in dollars. So this model in this like housing price example would learn the relationship between the features and the labels. So it would be able to learn the relationship between the prices of the homes and the different features of the homes as well. So we can also split our data. Like data is used in 2 main types within machine learning. It's overall very important, but it's also split into 2 different kind of subsections that are important within themselves. And those 2 subsections are training data and testing data. So training data you can kind of think about as like literally training data, like your homework set, and testing data is testing data, like the exam set. So you train with homework and practice problems, and you test on the exam. So It's really important to have both of these types of data because you want to train your model, obviously, to make sure that it's able to understand different types of data, but you also want to test it. Just because it does well in training doesn't mean it's going to do well in testing because you don't know how it reacts to something it hasn't seen before. And that's why, like, if y'all have all gone through school and you know that feeling when it's like you study so much, you train so hard, and then you get to the test and you're like, I've never seen this before. And the whole point of that is they're trying to make you use skills that you learned before to, and like patterns that you've seen before, and apply those to things you haven't seen before on the exam. That's how they test deep learning. And it's the exact same way for machine learning. If we just test on training data, we might think that the model is absolutely perfect because it's really well at regurgitating something that it's seen before. But really, it's just memorizing answers. It's not actually that good. And that's kind of what we call a concept we call overfitting. So if you like think about a student, like you probably have seen this student, maybe you are this student. They've like memorized the exact questions from all of the practice exams, like homeworks and everything. They have everything down, but then they keep failing on the actual exams. And that's exactly how machine learning models work. They are perfect 10 out of 10 on data that they've seen before, but new data, that's where they really struggle because they haven't been like seen that they haven't seen that before. And that's the point of training or testing, so that we can see how the model is able to adapt to data that it hasn't seen before. So we can kind of think of the machine learning pipeline as this like kind of 5-step process. And I say pipeline in terms of like how machine learning works. So first you have step 1, which is where you collect the data. And the data is like this raw material. It's just like raw data, like it's not really processed, it's not really cleaned, it's just kind of data, and like it's not really organized. The second step is preparing that data. So now you're going to clean that data, format that data, remove all the values that you don't want, make it really clean and understandable for the model. And the third step is training the model. So you want to train the model by feeding the model different patterns within your data and helping your model identify those patterns. The fourth step is evaluating your model. So you want to test your model, again, this is that testing data, to see how well your model learned. Your fifth step in this machine learning pipeline is deploying your model, so letting actual users interact with your model. So this is kind of less of a fifth step and more of like a final, like what you do at the end. So we're going to walk through each of these steps, but we're going to be focusing on the training and evaluation steps because I think those are the most important steps when you're just starting out and trying to learn about what machine learning is and the different processes within it. I know it feels like we're like breezing through these sections, but that's just because the first couple of sections are like very beginner focused and very like calm, but the rest of the sections are more like code intensive. So don't worry, we are doing well, and y'all are doing well, but paying super close attention, hopefully. So this is kind of a deep dive, I guess, into supervised learning. So I talked about those 3 different learning styles. This is kind of an very deep overlook of what supervised learning is because that's kind of what we're going to be covering. So like I mentioned, in supervised learning, your model will get both the question and the correct answer during training. And basically what your model is doing is trying to find a mapping from inputs to streams. Ooh, hello. Is there a part 2 of the stream? No. So this is kind of like a 1-part series, I guess. Like basically sometimes Global Hacks Weeks, we were in like streams like part 1, part 2, part 3, part 4. And this is supposed to be like a kind of part 1, part 2, part 3, part 4 thing. Like my tech track is called like How Things Work, like in time for beginners week, so that like I can teach y'all how like beginners concepts work and like how things like buzzwords work. But there is no part 2 to this one because this is kind of just like how machine learning works. The last one was how web apps work. The next one is how cloud computing works. So these are individual streams, but they all have an overarching theme of like how things work in general. But there are some future resources that I can send y'all if you are interested in learning more about machine learning. And your community members did send some earlier, so just scroll up in the chat and you'll see all those resources that everybody sent you. So hopefully that helps. But yeah, like I was saying, in supervised learning, you're basically just trying to find the mappings from the inputs to the outputs. Like I was mentioning the flashcards before, you're basically seeing those flashcards, looking through those flashcards, and looking through the patterns in those flashcards in order to answer future questions. Yeah, totally no worry at all. Scroll through the chat. You'll be able to find a lot of the resources that your fellow community members sent earlier. And if you can't find it, no worries. At the end, I'll go over the resources like as a whole in a little bit, like maybe last 5 to 10 minutes. So that's a little bit about like what supervised learning is in general. And in machine learning, our tasks are mainly separated into 2 different categories. So we have regression and we have classification. You might have heard that term too. So regression is basically where you are predicting continuous values. So pieces of data that have like back-to-back values. So this might be like house prices or like temperatures, like a piece of data that can go from one value to the next value, like 75 degrees, 85, 75, 76, 88, and doesn't just like jump. So this would be like maybe estimating house prices, like what we were talking about, based on features, or like temperatures based on the next week. And the output with regression can be any number within a range, like within a range that you specify, which is why it's like continuous. And this is super ideal and very helpful for problems where precision matters, because now you have this range of numbers that you know works. On the other hand, you have classification, and classification is where you assign inputs into discrete categories. So I'm sure all of y'all have taken some level of math or know some level of math, and if you have, you might have like heard of like continuous versus discrete. Continuous is like a bunch of different like the same numbers, and then discrete is like like different categories that may or may not be back to back. So if, for example, or sorry, for pieces of data, like going back to our spam example, if you're determining whether an email is spam or not, then that would be a discrete category because it's spam or not spam. It's not really continuous because it's like one or another. So you can think about classification for categories and regression kind of for numerical types of data, because regret or classification deals more in the categories where there's like non-direct back-to-back answers. So we can kind of think about classification as outputting labels or classes, and this is why classification is really useful when you want to sort data into distinct groups or categories. You can use both regression and classification for machine learning. Like, in fact, you usually do use both of them to use a lot of real world machine learning applications. It's quite important to use both of them most of the time. But that's just a quick introduction into what the difference between the two is. And you can kind of think about how a model learns. Like, I know I've talked a lot about like, oh, you can do training and testing, but like, how does a model actually learn? And a model learns by adjusting its internal parameters. And you can kind of think of those as like, I guess, knobs controlling how the model makes predictions. So during training, like when the model is fed training data, the model basically tweaks these parameters to better fit the data that it sees. So it gets data and it's like, my rules that I have right now, the patterns that I identified, aren't really helping me for this data. Let me tweak my rules really quick. And then it like adjusts its parameters on the inside of the model. And the goal of this training is basically to find the perfect, like ideal combination of parameters that minimizes the difference or like the error between what the model predicts and what the answers that we gave the model are. So the model continuously tries to fine-tune its parameters and adjust its parameters to decrease this error. And then by continuously doing this over and over again, very repetitively, the model is able to make more accurate predictions on data that it hasn't seen yet. And that's the purpose of training data, so that it can make better predictions and more accurate predictions on testing data. So something related to machine learning that you might hear a lot is like a way to measure how well a machine learning model is performing. And that's called a loss function. So you might have heard about this in calculus, or maybe this is the first time hearing it. But a loss function is basically just a math function that takes whatever predictions the model generates and the actual values that we tell the model, and it compares the two And it returns one number that represents like the kind of cost of the errors that the model makes. Obviously, this isn't like a real cost, it's like a fake cost, but that's why it's called a loss function. We are estimating how much the loss is in terms of errors. So if you have a smaller loss, obviously that means the predictions are closer to the truth, and a larger loss means that the predictions are further off and the model needs to be more fine-tuned. So during training, the model can use this number as feedback to adjust the model's internal parameters so that it can make better predictions in the future. Yeah. We usually use like mean squared error for a common loss, basically just like taking the difference between the predicted value and the actual value, squaring each difference, and then averaging all of those differences. That's usually like the biggest, most common error that people will use. And yeah, the training process is basically just optimizing to make sure that we are minimizing whatever loss we get. And by continuously reducing this loss, we basically guide our model towards better and more accurate predictions as well. Um, Final concept that I'm gonna like go too in depth into. Sorry, I know this is like a lot of yapping for me, but like I really couldn't find a better way to like talk to y'all about these concepts without just yapping. So hopefully this is like somewhat interesting, but I promise it's all gonna come into use into our demo. The final concept is gradient descent. So you can think about it like color gradients, like the color gradient on the screen from purple to pink. And gradient descent is basically the algorithm that is optimizing model parameters. It basically just keeps moving the model parameters in a direction that reduces loss. So a model is like, oh, if I go right, it reduces loss. Then you're just going to keep tweaking the parameters to move the model further right. And yeah, that's basically what that is. Um, Moving on to the next section, data preparation and feature engineering. So like I was mentioning, it's really important to clean data. We have data in the real world and it is super messy because it's not made for machine learning. It's just made for collecting data. So we'll often have things like missing values, duplicates, or outliers, all of which cause problems for our models because they don't know how to deal with that. And that's why we clean data so that we can have really high quality training data. And sometimes in machine learning, like the features that we were talking about, so like bedrooms, number of like bathrooms, square footage, things like that. These are features, and these features might have different scales. So, like, maybe like bedrooms range from like 0 to 10, but income for like the owner of the house might be like 10,000 to like 4 million. 10,000 is not a little like, but yeah, but these differences are like they cause lots of problems for the algorithms because like the scale is crazy. It can go from like 1 to 20 and then it just goes like all the way up to like 4 million. So it's like it shoots up to some crazy number. And so that's why we use feature scaling techniques such as normalization or standardization. And we use these techniques so that we can bring all of our features within like a similar range of numbers. So we're not like jumping from like 20 to 4 million. And this helps models basically converge faster and determine their parameters faster. And that way they can improve their overall performance by treating each feature way more equally than if it was another way. So with converting categorical features, when we are working with machine learning, our models can only understand like numbers. They don't really understand words or categories like how we were talking about, like maybe like different colors, like red, blue, or green. So when our data set includes categorical features, so things like maybe color, gender, or type of animal, we need to convert those different categories into numbers. And that is called feature encoding. So converting categories or different types of topics into numbers. And the two most common ways to do this are label encoding. So that's literally just like red 0, blue 1, green 2. And then you can also do one hot encoding. So instead of assigning numbers, one hot encoding basically just has binary columns. So like if the number is red, then it's 1, otherwise 0. If it's blue, 1, otherwise 0. So you'd have like 3 separate columns. And for each of these data points, only one of the columns will be 1. The rest will be 0. So that way there's no relationship. You just know what each of these values are. And you can pick either one hot encoding or label encoding. Deciding between the two which to pick, some of these algorithms, maybe like decision trees, could handle label encoded features like just fine. But if we're doing like linear regression or neural networks, which we'll talk about in a little bit, it might be better with one hot encoding. So just make sure that you are converting your categories to some format that your model can understand, and make sure you do it in a way that doesn't like mislead the model and create relationships where there shouldn't be relationships. So I know that was a lot of yap. I know I just like talked a lot to y'all. Hopefully y'all are still awake. But we're going to go into a fun little interactive demo. So those of y'all that are sleeping, wake up. Those of y'all that have tuned out for a little bit, tune back in. We're going to be doing a fun little demo here. And basically we're going to do a live data cleaning exercise. So I'm basically just going to show y'all a sample data set. It's going to have some missing values and categorical features, and you're going to tell me in the chat. So get your chat fingers fired up, because we are going to type in the chat about what features are missing, what I should fill them in with, and what categories I should fill them in with. And whatever y'all say, I'll put in the data set. So make sure y'all are paying attention and you know what's going on so that you can give me the right code. Well, the right options. So I'm going to go ahead and go into my collab notebook. So hopefully y'all got that open. Remember, you can use whatever IDE you want. I'm just choosing to use collab so that, because I know it works and I've tried it before. But again, feel free to do whatever you would like. So we're going to go into Google Colab, and Google Colab is like double, triple extra cool, because with VS Code, you have to like insert, oh, sorry, I accidentally clicked plus for no reason. But with VS Code, you have to download some of these packages, and it takes a little bit longer, but with Google Colab, like it's just automatic, and I love that. So 10 out of 10. Hopefully I didn't lose too many of y'all during the 42-minute yap session. But basically here, what we're going to do is we're going to go ahead and import pandas as PD. So basically what this does, pandas is a really important data set. It is very, very useful for us. And it's kind of like a data set that we can use. It's basically like a Python library, and it's really useful when we are working with data sets, because it has a bunch of different functions for like analyzing, cleaning, exploring, and manipulating data. So very useful library. We're going to be importing that so that we can use it. And I'm doing like import as PD just so that I don't have to type out pandas every time, and I can just do PD. I know it's not that deep because pandas is a short word anyways, but that's why I'm doing PD, just so it's a little bit easier to type. So I'm going to create some fake data here. And feel free to create this fake data along with me. Feel free to add some features. I'm going to do age as one of my pieces of data. I'm going to do like 30. Like random values. And you'll notice I put none for some of these, and you'll see why I'm doing that in just a little bit. But this is basically just to mess up with the data, like mess the data up, basically, because like imagine this is a survey that you're collecting from like the general population. You don't, like, some people won't respond to this. Like if it's not a required question, people won't put their age, they might not put their gender, they might not put like whatever features there are. So it is really important to be able to accommodate for that, and I'll show y'all exactly how to do that. So I'll do male, female, female, male, non-female. Again, completely random pieces of data that I'm working with. I'm just doing whatever I want. Feel free to do as you see fit. I do income, and again, completely random numbers. This is no indication of like what I think is an income or anything like that. I'm literally just typing random numbers. Pretty much all in the mid like 50 range. Yeah, so that's my income. I'm going to end off with that. It looks like it's not happy with me. It's because I forgot the commas. There you go. There you go. Now it's happy with me again. Yes, I made like a little set, and I had to put commas to make sure that each of my elements had that specific pair. So then I'm going to do df. I'm going to create a new variable called df. I'm going to do pd.dataframe. And I'm going to pass in data. So this is just a way to represent your data within a frame. And this is that function. Let me see. The AI auto-filled in the random data for me. That's great, man. I'm glad to hear. AI is definitely evolving. Yeah, feel free to use that if you want. I just typed it out for those of y'all that didn't have the AI do it. But if your AI filled it out, go ahead and use it. It's fine either way. Just make sure that your AI filled it out with a couple of none values, because like that's going to be part of the demo that I'm going to show y'all. But even if not, you can just add it in, no worries. So I'm going to print this out, and I'm going to do, I'm going to tell my user, so this is our raw data. data. And I'm going to backslash n, and I'm going to comma df. And I'm going to pass in my df, and I'm going to hit play. And boom, there is our data. So this is a quick code in section that basically displays some of your data out in this form using the pandas library from Python. And you can see I've got my age, my gender, and my income. You can see it's like NaN or none. Some of these pieces of data don't have values. So you can see those missing values. And I want to know, so how do y'all think we should fill in the missing age values? So this is that what is that? This is that interaction that I want to hear from y'all. So what do you think is the best way to fill in age? Should we do mean, median, or something else? JK, it's just mean or median. Pick. So I want to see some responses in the chat from y'all. Do you think it would be a better idea to fill in the mean or median values for the missing age? Okay. Seeing a couple of responses come in. Skits Twitch says median. Okay. I'm not gonna say if that's right or wrong, so to see if I can get some more responses. Okay, Tris B also thinks median. Okay. Noob says median as well. Don't let crowd or herd mentality make your answer, guys, if you feel like it's something different. Okay, yeah. Obulax thinks it's mean. Okay, interesting. Oh, Vienna has a reasoning. Median because mean may have decimals. I like this complex reasoning. This is good. Okay, looks like the answers are slowing down. So I'm gonna tell y'all what we're gonna use. We're gonna use median. It's definitely best to use median as opposed to mean. And the reason for that is because we want the median of all the ages that we're getting. If we were to do mean, again, like it's okay to have decimals. Like you can see that the system takes that, but like Vienna's saying, we don't really want a mean for an age. Although that does make sense because like, maybe your birthday was like 3 months ago, so it's like point, like, something like a decimal. We want the age to be the whole number. So we're gonna be using median. And similarly, so great response. Y'all did great. And I love that y'all have so much engagement. Please don't be afraid to put any wrongs there. Like, even if it's wrong, I don't really care, and nobody's gonna remember past this. So, also, what do y'all think for the gender column? Should we do a one hot encode or a label encode? What do y'all think? So for the one hot encode, that would just be like an easy binary 0 or 1. With the label encode, it would be like male or female or unknown or something like that. So, what do y'all think? Okay, seeing a couple of labels. I might have misled y'all, so there's not really like a right answer for this one. This is more just like, what do you want to do? Trisby says, yeah, since like some people identify outside of that. Yeah, exactly. Label encode, since there is no order. Yes, for sure. I definitely think in this example, label encode would be better, just in terms of like, because you're right, like some people identify outside of that. It's a little bit easier because there's no order. But I'm going to go ahead with one hot encode just because it's a little bit easier for us to implement that like on a live stream and for y'all to type that in. With the labels, like it's going to take much longer to do that. But I'm glad y'all caught that. Label encode is definitely the move there. So great job to all of you. All of you got it right. 100% accuracy rate. So 10 out of 10 there. We're going to add some information. So the perfect thing about collabs, I can just add in a new block and copy and paste that, and now I can add to it. So basically what I'm going to do is I'm going to fill in those missing values that we had before, and I'm going to fill them in with the median for age and a one hot encode for gender. So right here below my print statement, so I'm going to delete my print statement. I made my data frame, and here I'm going to do df bracket and age. And I'm going to set it to df age dot fill NA. So this is like filling those values with whatever I put in these parentheses. I'm going to do df again, df age, and I'm going to do dot median. So that's my median function, and I'm going to make sure that it uses, doesn't look happy with me. What happened? df age median. What's up? Was not closed. I did close it. Oh, oopsies. So we're going to fill in the values for age with the median. I'm going to use the dot median function for that. And then I'm going to use the one hot encode gender, and I'm basically going to fill in the first fill missing in with the unknown. So I'm going to do df, and I'm going to do gender. And I'm going to do again df, gender again. And this time, again, the same dot fill NA, but this time first, I'm just going to fill it all in with unknown. If you don't know it, you don't know it. That's all. df equals pd.get, and here I'm going to do .get dummies. And you can see what this function does, but basically, it converts the categorical variables into the dummy and indicator variables. So this is why I was saying it's easier to use the one hot code encoder instead of the labels. Y'all are 1000% right. Like in this case, if we were like actually making a project and this was important, and we were actually going to be like continuing development with this project, we would want to do label because it would just be more clear. But in this case, just like for convenience sake, and also so I could show you all some of these different functions, we're going to use the .get dummies function just for clarity's sake, and also just to expose y'all to some different methods. So we do df, and then we're going to set the columns. We're going to set them equal to gender. So that's what our columns mean. And if you're curious why we went through and did unknown first, it's basically just because like if like male or female, it's going to be 0 or 1. If it's nothing else, if it's not male or female, if there's nothing there, we're just going to label it as unknown. And I know that there's like, there are definitely identified identities past that, but this is just like assuming very basic data, like the most basic survey data that could be collected, like if there was just male and female options, but for sure there are more identities outside of that as well. So we're going to print, and we're going to do cleaned data. Clean data, and we're going to do the same thing. We're going to do \n, comma df. So now let's see what that does. Okay, it doesn't look happy with me. Let's see what happened. df age. It's because I forgot the bracket. That is on me. There you go. If y'all didn't see me do that really quick, for the age category, the square bracket doesn't wrap the filna function, but the brackets. Oh yeah, you caught my error before I did. 10 out of 10. Yes, you are correct. That was a mistake on my behalf. It's just the brackets around age, brackets around gender, and there are no brackets beyond that. Good job, Vienna. That was a quick catch. Nice. When you filna unknowns, does that not replace all the values with unknowns? How does get dummies return something different? Yeah, for sure. So does that not fill? Oh, yeah. So basically what this does, the dummies like function, it converts each variable into 0 or 1. So like columns in the output are named after each value. And what this does is like, remember how I was saying it's like one value across all the columns. So gender none is going to be set, like we have one unknown here, well, like one none. And so it's going to, even if it sets all of them to none, it's going to make sure that we go through each of these and check if we have a variable there. Variable there. And if we do, if we have male or female, then it's going to say false or true, which is why like for this one, so you can see that this is male, and then this would be female, and then this would be female. So even if it goes through all of them and fills them in as unknown, once it gets that and passes in the data frame, it'll repopulate those variables. No, you're good. You totally understand how it works. You just had to click slightly confusion. So hopefully that made it a little bit more clear. Let me know if you have some more questions beyond that. But yeah, so this is the clean data. So we can see like it looks a little bit better than the raw data. Like it still's got our age and our income, but you can see that we've got like the female, the like genders, whether or not it exists listed out. So basically here we replace the missing ages with the median ages. And the reason why we did that is to avoid bias from outliers. Because if we have all of these ages that don't have values, it's going to like throw off the data. do we need to copy the previous cell codes like we imported pandas twice? No, we don't need to. I just did that again so y'all can see the separate code. Feel free to not. It's been imported once. No worries about that. But if it is giving you an error, like this is genuinely one of my first times using Google Colab. So if you do that and you don't copy and paste it, and you're just doing it, like actually, let me just see if that works really quick. That does not work. Yes. So each of these code segments need to work within itself. Like they need to work individually. So you do need to copy it all fully. I think they're like individual pieces of code. So I do think you need to import pandas twice. In fact, let's just try it. What if we don't import pandas? Oh, no. Importing pandas once is fine. Okay. So you just need to make sure that all the data is there. You don't have to import pandas twice though. Good question. So yeah, we replaced those missing ages and we filled the missing gender with unknown, and we created separated binary columns that way so that we could have our gender category and we could use one hot encoding. Obviously, y'all know how to do label encoding. That one's pretty self-explanatory. I wanted to do an example with one hot coding to teach y'all a little bit about how to do that. And we can confirm that that cleaned data frame prints correctly. So that DF is our data frame. Like it prints perfectly. We see our gender female, gender male, and gender none. And we can see our like 0, 1, false, and true values there. So that's a little quick interactive demo with how to go through data cleaning. So obviously you can manually go through the data and like for this case specifically, like we could just change it here, like change the mean value, change it to median value, and then just like make sure that we separate out the nuns. But when you have really large sets of data and you want to scale, it's very, very difficult to do that manually. So that's why we've got functions like dummies, and that's why we've got like median to make sure that we can add in those values as well. So hopefully that makes some sense. And hopefully y'all were able to get that working. Let me know if the code didn't work for you. I'm here for y'all. If it didn't work, like let me know. We can troubleshoot it. We can work through problems that you're having and make sure that we get that figured out for you. But if nobody's having any problems, I'm going to switch back to the slides, and we're going to work on some model training and evaluation. So I've been talking about models a lot, like specifically I've been saying the word models like a bunch, and choosing a model is really important for machine learning. So we've got like a bunch of different types of models. I guess some examples would be like linear regression, decision trees, neural networks is something else you might have heard a lot. And there's so many different types of models overall. So today we're just going to do a very basic linear regression for a regression problem. This is probably one of the more simpler models because it's easier for beginners. But if you're interested in any of those other things I said, maybe you've heard like the neural networks buzzword a lot, definitely make sure you check that out too, because I think that the different types of models are very cool. That's why they've got all of them. They're useful for different purposes. So we're gonna go back to our code, back to our Google Colab, and we're gonna just scroll down and just add a new code block here. I'm gonna click new. Oh, damn, added that in somewhere random. Oopsies. Okay, there you go. So I'm going to show you all how to do model training. So this is going to be a bit longer of an interactive session. Like the last one was just like a quick one. This is going to be a little bit longer because we're actually like training the model. But we're going to import the libraries that we need first. So basically I'm using a bunch of sections from different libraries. And this is just a library I found on the internet that has like good data sets. You can use anything that you want, but Google Colab is really useful because it gives you like, it tells you if models are good or not, which is cool. What exactly we are doing in Colab? Yeah, for sure. So before I just showed y'all how to do data cleaning. So like I gave y'all this sample data set that had, you know, a couple of invalid pieces of data and like some messed up pieces of data. And I showed y'all how to clean that and how to do one hot encoding. So now we're going to be going back to Google Colab because I'm going to be showing you how to do training and testing for data for models. Hopefully that helps. So yeah, like I was mentioning the different models, and if we've got time, I'll show you. I was basically testing another model or another library, and I got this notification that was like, this data set is not ethical. Please use this other data set. And I thought that was super cool because I don't think VS Code does that, but it's really cool that Google Colab kind of has that built in so that like it can make sure that you're not using something that's like outdated or unethical or has been shown to be problematic. So I think that's super cool. And that's a really cool feature of Google Colab too. So if you're using like a model that you haven't used before and you're not sure if it's like right, Google Colab will vocalize that and tell you that it's not. So back to Google Colab. So I'm gonna import 4 different libraries to get just like our data for this. So I'm gonna do from sklearn.datasets. And this is super cool. It's just like a bunch of different data sets from this library. And I'm going to import something called Fetch California Housing. And it's basically just pieces of information about California's housing system. I chose California just because like I like California. I'm curious about the housing there. I know people complain about the housing prices in California like all the time. So curious to see if it's really that bad, which we're about to see. So I'm going to do that. And then I'm going to go ahead and do from sklearn. I'm going to do dot model, and then I'm going to do underscore selection, import train test split. So you can see the different models they've got here actually. Okay, you can. That's fine. But we're going to be using the train test split model because we want to split our data within training and testing. We don't just want to have all test and all train because I want to show you all how both of those work. And also, I know that I'm on the Google Colab tab, but like feel free to type in the chat at any point because I'm switching back and forth. And then we're going to do against from sklearn.linear model, import linear regression. This is that regression that I was talking about earlier. This is what we're going to be doing. And then finally, and then from sklearn, last library that we're importing, I'm going to do import mean squared error. This is what I was talking about earlier with like measuring error and how MSE or mean squared error is a super good way to measure error and usually a way that people will use in statistics. So if any of y'all took like AP or IB statistics in high school, or maybe you just took statistics in college, or maybe you've just seen statistics before, you might have heard of mean squared error. And this is a really good way to measure error. So those are just the libraries that we'll be needing. And then I'm going to load the California housing data set. So what I'm going to do is I'm going to create a new variable. I'm going to do housing equals fetch California housing, like what I did before. I'm going to import that from that library. And then I'm going to do x equals housing.data. And then followed by y equals housing.target. There. So I'm basically just loading the data set in, and I am loading it into data and the target values so that I can get that data into specific sets. I see some of y'all leaving. Bye. I know it's probably late, or maybe you're just tired. This stream does go on until 1 more hour, though. It's a 2-hour technical stream. It might be a little bit long because maybe you're used to the 1-hour technical partner streams, but this one is 2 hours. So hang on for a little bit longer. I will definitely make it worth your while. And now we're going to split the data into the training and the testing sets. So I know like when we say split, it kind of sounds like 50-50, like maybe we split it equally into training and testing, but we're actually going to do an 80-20 split. And the reason for that is because we want the majority of our data to go into training because we want our model to see as much as possible. And then we're going to do 20% of that data into testing because even though we're doing most of it in training, we still want testing. You can do whatever split you would like, but typically we do an 80 split, just 80-20 split, because that's like industry standard. We want the most amount of data going into the training, but we still want some data going into the testing just to make sure that the that the model is able to test properly on data that it hasn't seen before. So we're going to do x underscore train, comma, x underscore test, and then y underscore train, and then y underscore test. And we're going to set that equal to train test split, this model, and we're going to pass in x, comma, y, comma, test size. Oof. And we're going to set that equal to 0.2. Don't worry about that, not really important. And then random state. Wow, 42. That's not important either. Don't worry about that. But the X and the Y are just parameters that we're passing in for labels and features. So once we've done that, we're going to print a statement, and we're going to print exactly F training samples. And we're going to do bracket X underscore train dot shape. And that's going to make sure that we shape that data into the 0th column. And then we're going to do comma testing sample. Oh, forgot the comma. Testing samples. And we're going back to X underscore test. Oh, I forgot my bracket. X underscore test dot shape. 0. Okay, so basically what this code segment is doing is we are loading that data set like we've got up here, and we're going to be loading different features. You can't really see it, but it's more features like crime rate, rooms, house prices, things like that. And then we're splitting the data into training and testing sets so that we can evaluate it later. So, and it's going to print out what the data looks like, so we can try that. Oh. Let me see what's going on there. Looks like we're getting an error. Let me see how to fix that really quick. Ooh, explain error. Oh, that doesn't help. Oh, wait. Maybe let's see if AI can help us debug this. Oh, oops. Okay. AI coming in clutch. I forgot to do the double parentheses at the end of the word housing. So it just had like fetch California housing, as opposed to like fetch California housing with parentheses, which helps identify that it's a function. So AI coming in clutch there. That was super helpful. And we're going to do our data and target. And we're going to be making sure we've got our fetch California housing. So basically, if you're wondering what that is, we're just loading the California housing data set. So we've got these different variables, returns the data set. So you go through some of this. It's like data home, pandas, target, returns the truthful if it's true. Data comma target. Target is a pandas object. Yeah, that's super cool. Oh, yeah. So target, actually, that is crazy timing. I actually just went into a little bit what target was, but so that's something specific to this data set. So you can see this, like it's got printing the shape, printing the names, printing the housing. So like shape is just the number of values there. But it prints out a bunch of different features. So we've got like our labels, and then we've got our actual data. So let me go back and see if I can actually get it. So it returns it kind of like as an object, which means that it's got our different pieces of data and then our labels. So you can see that like this is a crazy big number, and then this is a super small number. And that's because like this is the actual data, and then this is the like target, which is the labels. So hopefully that helps. It's just data comma labels basically. And yeah, that was super cool how AI debugged it. Power of Gemini, y'all. Super useful, super helpful. Yeah, that was cool. I was like looking through it and I was like, what is wrong? And then I saw like AI can help. why not just let AI help? So that was useful. But yeah, so you can see those are our training samples, those are our testing samples. The training sample number is much bigger than the testing sample number, and that is for a very good purpose so that we can train our model with more data. And now we're going to create our linear regression model. So we're going to do model, and we're going to set our model. Ooh! You can see AI trying to auto-generate, but I'm not going to take that. I don't know what all that is, and I don't really want to. Actually, I mean, I guess I could. Oh, I don't want all that. Yeah, let's take that out. Okay, so basically what I did here was I made my linear regression model, I initialized it into the model variable, and I fit it onto our training data. Fitting it basically just means that we are using our data and we're using our model, trying to get our model to accommodate to our data. And that's why I did X train, Y train, and then I'm just gonna print like, oh, model training is done. Yes, Mingo. That is very funny. We are using AI to code AI. Technically, this isn't AI. Like, I think that was something I was super confused about in the beginning too. AI is different than artificial, or no, AI is different from machine learning. Artificial intelligence is like how we get machines to think like us, like how we get machines to think like humans. But machine learning is a little bit different. That is how we get the like how we get machines to think like us. So it's like artificial intelligence is like machines think like us. Machine learning is how we get machines to think like us. So you can think about machine learning kind of being like under artificial intelligence. It's like the way that we develop artificial intelligence. But yes, we are using AI to code ML, so that's super funny. Yeah, okay. So we did that. We went through the training data. We initialized our linear regression. So we finished, we got our print statement, and now we're going to predict on our test data. So we're going to do y pred for short for predict, and I'm going to do model.predict. Okay, it looks like it really wants to generate that for me. That's fine. So we're going to make predictions on unseen test data. So model.predict, and we're using x.test. Notice the difference between x.test and x.train here. So here, we're just fitting our model using this training data, but here we're using our model to predict based on this test data. So a little bit different there. And then after we've done that, the AI generated this fun code for me. And it asked for the mean squared error. So it takes y test and y predict. And the reason why we use y here is because, again, this is our target. So like Trispy was asking earlier, our target is our label. So those are the patterns that we want our machine or our model to identify. And here we're testing the error between what we have the model predict what we want the data to be, and then what the model predicts. And then we print that out. And it's going to give us a variable. So we're going to calculate our mean squared error to measure error. So I want to see if some of y'all were paying attention and if you knew what mean squared error is. Do we want a lower or a higher mean squared error? And what I mean by that is a lower mean squared error better, or is a higher mean squared error better? And I want y'all to respond in the chat and let me know. And while you're responding, I'm actually going to go turn my lights on. It's looking like it's getting very dark, so I'm just going to go turn my lights on in a quick second while y'all are typing your responses in the chat. Okay, I'm back. Hello. Sorry, it's getting like super dark. I couldn't even see my screen anymore. I was like, I don't know if you noticed, I was like turning my like screen off and on because I was like, I literally couldn't see anything. But okay, seeing a bunch of answers. Lower, 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 and lower, because it represents the difference between the expected and actual output. Lovely. I love the reasoning. But yes, all of you are indeed correct. It is lower. A lower MSE is good. I'm loving this interaction. I love seeing like the same names pop up again and again, because I'm like, oh, I know you answered that before. Y'all are doing so well. So yes, we are doing lower, and we're going to go ahead and try that out and see how our model performs. I'm just gonna go ahead and click plus, and you can see that our print statements worked, and it printed out everything that we wanted it to do. So it's got it going for us. Am I? Yeah, so we've got our training samples, our testing samples, model training is done, and our mean squared error is 0.55. So that's like middle. It's like, okay, it's not great, it's not horrible, but it's good. So that's our model. We tried it on that data, and I think that was 10 out of 10, pretty cool. So that's just a quick example of how we can train our model using training and testing data. And you can keep like fitting your model better, trying cleaning up the data, do a lot of different things to try and make sure that the model can react better and predict better data. So yeah, after training, we evaluate the model's performance using different metrics. Like here, we use one metric for like for example, with linear regression, you typically use mean squared error. And like Vienna was saying, that does calculate the average squared difference between predicted and actual prices. And like all of you said, lower MSE does mean a better fit for the data. And I talked about this a little bit earlier. Overfitting is when a model learns the training data like way too well. And when it learns the model training data too well, then it's going to perform really poorly on the new data. And then we have underfitting, which is the exact opposite of overfitting. That's when the model is like kind of stupid, too simple, and it's not able to capture a pattern. So it doesn't do well on the training data either. And we want to find a balance. We want to make sure that we don't underfit or overfit, and we just have like perfect. So that's what we do with training models over and over again. And yeah, so that's a little bit about that. And we can also talk a little bit about like a little bit advanced beyond the basics. Oh yeah, for sure. Can you explain a little bit more about what's happening with mean squared error, why test, why pred when you get a chance? Yeah, for sure. So basically what this line of code is doing is it's taking the mean squared error. So like, let's hover over this function. It'll tell us what that means. So it's basically taking these two let me go back. It takes one of these and it takes the other. So it takes a data set and another data set of what the difference is, and then it's going to take a number based on whether or not that difference is like there. So I think it makes more sense when you have like actual numbers. But for this specifically, yeah, what comparison is being made behind the scenes? I think this would make more sense if we had numbers. But here, since we're doing labels, it's comparing whatever label it is to what label it's supposed to be. And it has like kind of a range for that. So it goes through mean squared error, which is taking the average squared difference between predicted value and actual value. So that's just going to be like whether or not it's true, and then it keeps narrowing that down. So hopefully that helps. It's basically just mean squared error algorithm being run on that data. Let me know if you have more questions. Sorry to interrupt. Is this live recorded? Yes, it is, for sure. No worries. Don't be sorry to interrupt. That is exactly why we have a chat, and that's why I keep pulling up y'all's answers. It is recorded. I am live streaming to YouTube right now, but as soon as this is over, you can watch it on YouTube. And also, like, if you missed something now and like something's not making sense to you, or you came a little bit later, you can always go back and like rewind on YouTube. I don't think you can do that on Twitch, but you can always just switch over to YouTube. But yes, it's being recorded. Yeah. Okay. So we talked a little bit about underfitting and overfitting. Also a little bit about unsupervised learning. This is mainly supervised learning because we were giving the data the labels, but in unsupervised learning, there are no labels. And the model is basically trying to find these patterns by themselves. And then we've got like our last type of learning, which is reinforcement. Yeah. That's a little bit about like how we can do training and testing. Some more concepts that I wanted to cover, just like in general. I want to talk about neural networks for a little bit. So neural networks are basically a type of computer program, and they're inspired by neural networks, or like how our brain works, like how our neurons interact with each other, how our neurons network with each other. You can kind of imagine our brain. Like if you don't know how the brain works and how neurons kind of look, we have these tiny neurons and they basically talk to each other. Each neuron has some sort of information or takes some sort of information, and it does like a process, maybe like a little math, and it passes whatever results that is to the next layer. By stacking layers of neurons and layers of neurons passing information to each other, the network is able to understand very, very complicated patterns within data. And this is really similar to how our brains learn from experience. So, a neural network is essentially modeled after how the brain works, and both of them work very similarly. When we're training a neural network, we adjust the strength of connections between all of our neurons to make better predictions. And this is like called back propagation. Like, I know that's like a hard term, but it's basically what the process is. And that's where the network learns from its mistakes and changes connections between neurons like a little bit by a little bit. And with enough practice, it gets really, really good at various tasks that machine learning is used for, like recognizing images or understanding speech. And that's kind of how our brain works too. Like, you may have heard the saying, like, your brain makes like so many new connections. Like, you need sleep so that your neurons can make new connections. Like, obviously, machines don't need sleep, but that's like the similar way that like they make new connections when they learn new things, learn new experiences, and they get more feedback. Then we've also kind of got deep learning. Deep learning is a specific, maybe special, like subtype of neural network that has like a bunch of layers. That's why it's called deep learning, because it has like a deep amount of layers. And by a lot, I mean like hundreds of layers. Like it's really, really big. Um, and these extra layers serve a really important purpose because they help the network of neurons learn from our data in very, very detailed ways. So, by having all of these layers of neurons within our neural network, we're able to like find hidden patterns, hidden features without the data without us telling the data what it needs to look for, like in terms of labels, which is why deep learning is super, super useful for solving very complex or like logic problems that are difficult because we've got multiple layers that look for different hidden patterns. And deep learning is really useful, like in terms of like modern day usage, because computers are able to do so much now. In terms of like, if you've ever gone through your photo album and you see that your computer is like, or not, your phone is like, is this Bob? Is this like Jane? There's this photo show, this person shows up in a lot of your photos. Do you know them? What's their name? So it's able to recognize faces in photos, like translate languages. All of that is because of deep learning. And we are able to power like so many pieces of technology because of deep learning and because of machine learning in general. So kind of another like super cool project that I wanted to do was build like a classifier. So I was telling you all about like, oh, like, like machines these days, they can like find out like who somebody is and like classify that person. So we're going to build like our own little native classifier. And we're going to be classifying flowers. I've been on a flower kick recently. Like, I really like flowers. I love the way they smell. Like, I love the way they look. So we're going to be classifying flowers because I was like looking through data sets and I was like, like what data set looks interesting? Like, what data set can I use? And I came up with flowers. So hopefully y'all enjoy that. Hopefully it's not like boring for you. But I think it's really cool to learn about the different species of flowers, see what the pictures look like, et cetera, et cetera. So we're going to go back into our Google Colab. Actually, we're already there. I say back into as we're like on the screen. Let me go back. So we are going to go back and start a new project. I'm just going to do it within here because I don't really care, but feel free to start a new notebook if you want. I'm just going to keep this so that like all the code for one stream is in one place. So basically, we're going to use that same sklearn datasets, and this time we're going to import a new dataset. It's called Load Iris, and it has a lot of data about flowers. So I'm going to do from sklearn, sk, not sky, sklearn dot datasets, and I'm going to do import load. Oh yeah, so look, you can see how many different types of data it has. So I just picked iris, like I literally just did load underscore and was like trying to find something that I wanted to do and I thought iris was cool. But you can load digits, like diabetes. I'm assuming that's like different types of diabetes, maybe like characteristics of diabetes, load breast cancer, load wine, maybe like different types of wine. Anum asks, how were you able to find the data sets? Yeah, for sure. So I like me personally, when I was preparing for this stream, like I was trying to find some cool data sets that were beginner friendly and were really useful for getting training and testing data from. So I basically just like Google searched like helpful data sets, and that's where I found the like Fetch California housing. And I wanted to do like after I like built out the code for that previous one, I wanted to do something like kind of more interactive and like wanted to do like one more interactive project because I feel like I've been yapping at y'all for a really long time. So I found the iris data set. Like I literally just did what I showed you. I did like load underscore, and I was like scrolling through this, and I was like, iris sounds interesting. Oh, iris sounds interesting. So I just went ahead with that. That's how I found it. Yeah, feel free to check out those other data sets on your own time, though. Those other data sets sound super interesting too. And we're going to import our pandas library again. So we're using both of the pieces of information that we learned. This is like our kind of like, I guess, final project. Like we've got like 35 minutes left. This will take like a big chunk of our time. And then we'll go into a wrap up. So get hyped for this next session. I'm going to call a new variable. I'm going to say iris equals load underscore iris. And I've got my brackets. So this is the function that is loading iris data into this variable. And again, I'm going to use my x and my y. I'm going to do iris.data and y equals iris.target. And hopefully whoever asked earlier about like data versus target makes sense now. Like all of your data is in data, and then target is just the labels, like the patterns that you want your model to find. And then we do df for our data frame, pd.data frame, exactly what we were typing before. X columns equals iris.feature names. I know the AI is doing exactly what I want, but I'm going to ignore it completely so that way I can show y'all that this is possible to do without AI. Can you explain the convention of the X being capitalized and the Y lowercase? Honestly, don't know why. I really wish I could tell you. I don't know what the convention is. It's just because like I was going through some of the documentation for this and I kept seeing like capital X, like lowercase y. Like even when you do the load iris, like do you see how it says like capital X, lower I? Let me actually search that up and find out the answer for y'all because I was curious about that too. And I was like, I don't really have time to do all that while I'm like trying to build out this stream. So let me search why. Why does L trading do? Oh, apparently the convention comes from mathematics. Apparently that is something that is commonplace in math. Oh, linear algebra. Okay, see, this is why, because I haven't done linear algebra. But apparently it's linear algebra notation. Typically a matrix is denoted by uppercase. But the labels, like matrix is like multidimensional, and that's uppercase apparently, but the labels are one-dimensional, which is like a vector, and that's lowercase. Interesting. Hopefully that answered your question. That's like a much more interesting explanation than I was thinking. I just thought it was like somebody forgot to capitalize the Y, but hopefully that helped. Yeah, cool. Glad you think so. I think it's super cool too. So we've got our PD data frame, X comma columns, and we've got our iris feature name. So basically our labels are going to be our columns. And then we're going to do we're going to do species because they're like flower species. And that's going to be set to our labels, which is our target. And we're going to print df.head. If you're curious what head is, it just returns the first n objects for the object based on position. Nice. Useful for testing. Yeah, just returns the first couple of pieces of data within your code. So the iris data set, that's what we're using right now. We're using the features and labels of the iris data set. And this head function basically just gives us the first 5 rows just so that we can see what the data looks like. You can see like the same thing happened here. Like it was the first 6 rows here, or yeah, 5 technically because like 0th, but yeah, it gives us the first couple of lines of code just so we can see the code or the data without being overwhelmed by how much data the data set truly has. So I'm just going to click paste there, print. So y'all can kind of see how that works. So the different labels that this iris dataset has, like sepal length, sepal width, petal width, and species. So let me actually show y'all what that is, because I was confused too, and I was like, what is this? Don't worry, I got y'all. I don't think that's clear. Okay, so for context, so the sepal length, this is the sepal, so like kind of like the little flower, like the leaf part coming off the flower. Petal length, y'all know what that is, like the petal of a flower, and like species of a flower. Let me see if I can find an actual. What is sepal on flower? There you go. Okay, so like an actual picture of a flower might help a little bit more. So like obviously these white parts of the petals and kind of like the green, maybe not green always, but like the protective covering over the petals is the sepal, for context. So back to the tab. Yeah, this is just a little bit about the data, with length of each of these things. Just a couple of pieces of the species as well. So let's go into that. We're going to keep going back into this data. So here, again, I'm going to import something else. So I'm going to put my import statements up here just for like clarity's sake. I'm going to do from sklearn.model _ selection import train test and split. Okay, once I've done all of that, I'm going to do the same thing I did before. I'm just going to paste that because I don't want to copy and paste all of that or type all that out. So I'm going to do x train, x test, y train, y test equals train test split of x, y, test 0, 2, random state. Perfect. And that's done. I'm going to print, and I'm going to do f training samples x _ train dot shape 0. I got my bracket again, and then I'm going to do my comma testing samples x. I got my bracket. I keep forgetting the bracket. X _ test dot shape and 0 again to get that 0th column. So here, doing the exact same thing I did in the other like mini project. I'm splitting it into test and train sets, and here, like, I'm assuming we don't have missing values because this is like a proper set. This is not something that I'm making up, so we don't need to do any data cleaning. That's kind of the benefit of using these libraries, is that they already have clean data, so we don't have to worry about like going through all the effort of cleaning that ourselves. So once we've done that, I'm going to go and add one more model. I'm going to do from sklearn. Again, the same thing I'm doing, logistic regression. So last time I did linear, this time I'm doing logistic. Couple more pieces of data, and also logistic regression is a simple classifier because that's what we're doing. We're classifying instead of linear regression this time. And I'm going to go in and add some more code. So I'm going to do model equals logistic regression this time instead of linear. And our max iteration, I'm just going to set it to, oof. Oh no, are we on emojis? Equals 200. And if you're curious why we're doing max iterations, let's check. Let's see if it has a documentation for that, for why. What is max iterations? Maximum number of iterations taken for the solvers to converge. So that basically just means the amount of times that the model can keep fine-tuning and like solving to find the classifier before it needs to come up to a result. So if you put like a higher number, it would be able to come up with more accurate results, but it's also going to take longer and it might time out too. So when we have max iter equals 200, that's setting our max iterations to 200, and that way we're increasing it so that we can ensure that it converges and actually classifies to something, and it's not just like, oh, I can't classify, I don't know what's going on. So that's how we increase that number. And I'm going to do it again. I'm going to be like, yay, training done. Dog training done. Okay. And then finally, we're going to, well, not finally, but we are going to evaluate that data. So AI already generated that for me with inline generation, but you can see it's got from sklearn.metrics, import accuracy score, so that we can see how accurate it is. So I'm going to do y underscore predictions equals model dot predict using our testing data. I'm going to do accuracy equals, and I'm going to set that equal to our accuracy score. And I'm going to pass in our y test and y predict. So this is basically the same thing here, except instead of mean squared error this time, we're going to be doing accuracy based on our accuracy score. This is our accuracy clarification score. So this is a little bit more complex than just mean squared error. This is like when you know what the labels are, because these are like specific labels for the species. So we can use that for this one. So yeah, accuracy here is able to measure like the correct predictions percentage, which is really important because we're trying to predict the correct species. And again, it's actually in contrast to the mean squared error, because with mean squared error, a lower MSE value was better, but with accuracy, obviously a higher accuracy is better. So a little bit different there, but very similar. I'm gonna do another import statement, numpy as nump. If you're curious what numpy is, we can, let me like, so like, I know it's a library for Python. So let me see what, like, oh, it's specifically for arrays and matrices. So it's just helpful for working with arrays and computing things with arrays so that it can look a little bit more clean and a little bit more clear. So here we're going to add some more code at the bottom. We're going to say new sample equals np.array, helps us create one. Let me just put in some like random numbers, 5.1, 3.5, 1.4, 0.2. Just a bunch of random numbers. These are our given feature variables, like we can see in terms of like sepal length, sepal width, petal width. Those are our 4. And then we've also got prediction. We're going to predict model.predict new sample. It's already got that for us. Model.predict new sample. So we actually don't need to create. I don't know why I put brackets there. That was unnecessary. And we're going to add something else. We're going to do species name because we want it to also predict the species name. So we're doing iris.target. It's got that. But we're also going to take the first variable of that. So the 0th column of that, we're going to take those values, iris.target names, target underscore names, prediction, and then 0 for the bracket. And yeah, we're going to do prediction for new species. Okay. Unnecessary is prediction species. And here we're not going to pass in prediction, we're going to pass in species name. Okay, so let me double check, make sure that's good, because I know AI generated some of our stuff. New sample, new, perfect. Okay, so we are using this predict here because we want to predict the class of a new flower with given features. So it has these features, and we want to predict what that new flower's class is. And the output for this is going to be a species name that we can read. So not something that's within the computer's code or the model's code, but something that like we as humans can see. And yeah, okay. So I want to try something. So I think we can just, yeah, you see like accuracy and everything. Oh. Did I format the data incorrectly? Damn. Oh, I just forgot another bracket. Oopsies. There you go. Okay. So sometimes it is useful to use AI to try to explain your errors, but sometimes it's just like you look through the code and you're able to find it. I think in terms of efficiency, it just depends on like what you want to do. Like for me, I think like using AI to explain the error sometimes when I'm like, oh, I looked into it and it doesn't really make sense. I'm not really sure. Or sometimes I'm just like lazy and I use AI. But for that one, it's just like, oh, I was missing a bracket. It's easy to figure it out. Yeah, so it predicted the species. So yeah, that was kind of like a cool way that we like made a model and we are able to like predict a species based on that. So I kind of want to see y'all participate with something really quick. So I want you to send me four numbers separated by commas in the chat. So it's gonna look something like this. So if you were to send me an example, it would just be like 5.1, comma 3.5, comma 1.4, comma 0.2. And it's going to be like this. Based on sepal length, sepal width, petal length, and petal width. Send me whatever you want. And once you send them, that's going to represent those features of the flower that I just went over. And once you send them, I'll use those numbers, feed them into our trained model, and tell you which iris species the model predicts, because there's a bunch of different iris species. So send as many as you want. We've got some time, so I can go through a bunch of different examples. So let me know, y'all. I'd be super excited to see what you think. Okay, we've already got our first one. Skits Twitch says that. Oh, I love the 11, 22, 33, 44. Good, good. Okay, so let's go in and add that to our code. So we've already imported numpy as np. So here I'm going to do a different section. I'm going to do user input. And we're going to copy yours. Well, I'm going to copy it. I'm just going to 1.1, 2.2, 3.3. Okay, and then I'm going to convert this like string of numbers to floats. So I'm going to do features equals np.array. Actually, I don't have to do all that. Let me just copy that. One point 1, 2.2, 3.3, 4.4. There you go. So now I'm going to make a prediction using these models. So predicted class equals model.predict. Well, I need to make another one. Species name. Okay, actually, let's take a step back. I'm going to go back and do what I was doing with the user input. So I think I'm confusing myself here. Or why can't I just do... Okay, I'm literally trolling. I'm just gonna... I don't know why I was like trying to make it like a complex thing. It's not that deep. I'm just gonna rerun it with this. Oh, okay. So for Skits Twitch, your prediction species is Virginica. Let's see what that looks like. Oh, that's such a pretty flower. Oh, that is so pretty. Nice. I'm not gonna fact check the model because I don't really care that much to like search up the sepal length and everything, but that's super cool. Okay, Trispy has got one for us. Hopefully you liked your flowers, Skits Twitch. If y'all want your own flower, definitely make sure you put a form of numbers in the chat. Let's try Trispy's here. 3, 3.6, 0.5. Okay, let's try that. Yours is Versicolor, Trispy. Let's see what that... Oh, sorry, I didn't show y'all. Basically, I just changed the numbers, and you got Versicolor. Let's see what that is. Basically, I'm going to search this up before I share my tab because I accidentally searched up versicolor and got like this weird skin condition. So versicolor flower. But that is a really pretty flower too. I like that all of these are like mostly purple. So pretty. Oh my gosh, I love flowers. Okay. Yay, glad you enjoyed it. A num is next. 4.9, 0.0, 12.4, 5.7. Okay. Let's try that. Okay, Virginica. So the same one that we had before on Nim. But if you need a refresher of what that one looks like, beautiful flower for sure. But same as skits. Donut guitar. Okay, 3.1, 4.1, 5.9, 2.6. Oh, it needs to stop removing the second bracket. I need that bracket before it throws an error at me. Okay, yours is also Virginica. Okay, it's looking like a lot of y'all's are Virginica. Donut Guitar, you are in line with Unum and Skits Twitch. Mango, let's see what you've got for us here. 1.3, 1.1. Keep them coming, y'all. I got time for y'all if you want to see what your flower is. Okay, let's try that. Setosa. Okay. Honestly, these all look very similar because they're all like, what is it? Variations of the iris flower. So they're all like purple and kind of similar, but you can see the slight differences. Like they look a little different. Their petal lengths are a little bit different. Their seal lengths are a little bit different. So there's some of y'all's. Let me see. Noob is our last one that I see in the chat so far, unless more come up. Yep, Virginica. Okay, super cool. Thank you all for that amazing engagement. That was so fun. So I'm glad that y'all got the chance to interact with that. So that's just like a quick like jump into machine learning to like see what we can do with training our model. So we were able to train our model and we're able to see what our prediction species is, which is super cool, I think. Yeah, so we're able to see what our model is able to predict. And you can keep checking it in the future too. Like in the future, maybe you could try checking like what it actually is to see how accurate your model is. But it looks like our model is pretty accurate. Accuracy looks like it's pretty high. So yeah, this is another way, and like we can also load different types of models and test out different models. Maybe not necessarily iris. There's like another one like breast cancer, like diabetes, wine. So lots of different options there. But let's head back over to the slides really quick. Yeah, project plus wrap up. We're in that section now. We just finished the project. I like wanted to talk about that last step in the pipeline that I was telling you all about, which is deployment. So again, like really big thanks to all of y'all for that amazing engagement. A lot of y'all were texting some fun numbers, so thank y'all for that. But I want to talk about deployment, which is like taking our model out of the notebook and putting it into the like real world so people can use it. And a couple of common ways that machine learning models are deployed are like APIs, embedded in applications, or in cloud services. And this is really important because by deploying models, we're able to kind of bridge the gap between data science and impact. by deploying these models, people can use them. So we're not just like playing around with data, and we're not just playing around with like data science. We're actually like creating an impact in the real world using our models. And kind of the way it looks like to deploy something would be like, obviously you train it, you test it in like maybe Google Colab, for example, and you would serialize your model, which just means saving your model. And you know how usually you save a Python file, it would be like .py. For models, it would be formats like pickle or onx, ONNX. And then you would build an API around that model so that your API can take input data, just like how I was taking input data from y'all and returning that prediction. And then you would deploy that API to like maybe a server or a cloud platform, and then you would monitor your model's performance. So that's just like a quick, very quick overview of how it would look like if you tried to deploy your model. And then I guess a couple of like baseline concepts that aren't really machine learning, but like important things to cover. It's very important to be ethical with machine learning. Machine learning can like unintentionally learn biases in data. Let me actually show y'all something that I looked at when I was going through my when I was trying to build out this project. I think I had the it's like Boston or something. So initially I was using the okay, maybe I'm lying to myself. Load Boston, that's what it was. Okay, so before I was using like Load Boston for like Boston housing data, but you're about to see really quick. Yeah, so this is what I was using, and then it was like it's been removed from the learn since like a specific version, and the reason for that is because like apparently the Boston housing prices data set had an ethical problem. They had like a variable that assumed something that was kind of discriminative, and like the research goal wasn't that straight. So the maintainers of the data set actually strongly discourage the use of the data set unless you're trying to understand ethical issues in data science and machine learning. So they literally don't even let you run the code. Like they're saying if you need that data set, you can go and take it from the original source. We like won't let you use it here. Like there's literally an import error. And I think that's really important because it's really easy to get caught up in like data science and machine learning and like all these fun terms. But data often has biases. That's just natural with the way that it's collected. And also, like a lot of data is historical. It might not have been able to collect data that we needed or that we had context for at the time. So sometimes it can lead to really unfair or harmful decisions. And it's super important to make sure that we are focusing on that. So, like, if you are coding in Google Colab and you're like, oh, what's wrong with this data set? It says there's ethical issues. Read through it, like, understand what's going on there, see why you shouldn't use that data set, and try to use something else that's a little bit more ethical. That's why I switched over to the California housing prices data set, because apparently that was more ethical. So something a little fun tidbit. And I told y'all I would get back to like resources that we can go over. Like my main resources were just going to be like go on Kaggle, build projects, learn about Python libraries with the skykit-learn and TensorFlow. But some of your community members had some really great resources. So someone said, Abiolak said the Andrew NG course on machine learning. Soham Active gave us the link for a Coursera on machine learning. Noob was talking about the Moosh Hamadani really good tutorial. Yeah, apparently Andrew NG's course also has financial aid. So definitely make sure you check out those resources. There's a bunch of resources for machine learning online. Like you are definitely not in a shortage if you are trying to find out more about machine learning. But hopefully those of y'all that started off as beginners were able to like kind of see how this was useful, maybe see if you're interested in pursuing more about machine learning in general, because it's like pretty cool in my opinion. And I I think it's like a really interesting like concept to learn about and to just like investigate. But yeah, lots of resources that are available for y'all, and hopefully you're able to go through some of those resources and like um, check them out. But I'm like trying to find something. Like there was like a resource that I was going through. Mm-mm-mm. Okay, yeah. Yeah, the Andrew Edgy course is super good. Lots of different. Oh, yeah. Donut Guitar says 3 blue, 1 brown's neural network series 2. There you go. One more resource for y'all. So, yeah, lots of different options for you. And basically just like quick summary of what we did. We talked about machine learning, how it uses data to teach computers patterns, which are those labels that we were looking at, and data quality, using good models, and evaluating your model on testing data are all really important. And we have to keep testing our model using like over and over testing to make sure that we can get these concepts down pat. Yeah, there's like the Coursera machine learning course by Andrew NG, really, really useful. And the SkyKit Dash Learn official docs are super useful too. So that's the end of our stream. Thank you all so much for taking the time to hang out with me for these 2 hours. Definitely check out this feedback link. This is the best way that we can make our streams better for you and make sure that you're getting the most amount of value from these streams. So if you have any feedback on this stream or any feedback from any of the streams at Global Hack Week, definitely make sure you fill out that form. Yay, I'm glad it was fun. Thank you for joining. I'll stay around for a little bit longer. If y'all have any questions, feel free to ask me anything. But by the way, here is the schedule for the rest of Global Hack Week. Up next, we've got our Understanding Python Environments Part 2 stream coming up with Alberto. And there's the check-in link for that. I'm going to end at 7:58 in 2 minutes just so that Alberto has some time to get into our like streaming session that we have here. So if you have any questions, make sure you type them and send them in soon because I want to end a little bit early so Alberto has some time. Thanks for the session. Yay, I'm glad you enjoyed. Oh my gosh, I'm so concerned with what time it is for you, but thank you for staying up to watch this stream. Hopefully you got something useful from it. Hopefully it was useful for you. Donut Guitar says thank you. Of course. Was here from both YouTube and Twitch. Oh, okay, so you're a double user. So there's a one less amount of viewers that are watching right now. I see. I don't know why you were watching from both. That's crazy, but thank you for joining from both. Mwahaha. Yes, exactly. You're messing up the stream numbers, but I don't really care. Yeah, so thank you all so much. Definitely make sure you check out this feedback link and fill it out. You can fill it out at any point. It's not just for this stream, it can be for Global Hack Week in general. And yeah, make sure you check out Alberto's event if you're awake and you want to see something else. He's going to work on Python environments part 2. Switch because of my Wi-Fi. Yeah, valid. Wi-Fi is really difficult. Sometimes Wi-Fi pisses me off. I wish it was like universal, good Wi-Fi, but I know that's not possible. If nobody else has any other questions, I'm probably going to log out soon. So if there's something that you're like dying to ask, get it in now so that Alberto can start his stream. I'm probably going to end at 7:59 in 1 minute because I see some comments coming in. But I want to end a little bit early just so that Alberto has some time. Yay! I am so glad this was helpful and I'm so glad this was easy to follow. Yay! If y'all have any follow-up questions, text them in the Discord Beginners Week channel. I will be checking that to see if y'all have anything that you want to inquire about past this stream. I'm always on the Discord. Well, I'm not always, that's a total lie, but I will check if you say something related to my stream. So okay, it's 7:59. I don't see any more questions coming in, so I'm going to go ahead and log off so Alberto has time to get into the StreamYard. But thank you all so much for joining. I really appreciate it. Have a good night. Take a good rest. Bye.